questions I did not understand my homework.
Which one? Let's start with
23 through 27. I didn't get those.
so because I think there's 23, 24, and then I think it's 26, 27. So we'll look at 23 first. We'll look at 23 and 26 for sure. And the reason I say that is because 23 because 24 is the exact same thing, just different numbers. Kind of see how that works. So we're going to do this one together. I'm going to let you guys try that one, 24, on your own. If you do still have issues with it tomorrow, or not tomorrow, I won't be here tomorrow, but Monday, if you still have questions over it, we can go over it then. Okay? I'm going to be worn out by the end of the day tomorrow. So the first thing we need to do with this, to write it in set builder notation, is to change it from interval notation to inequality. So this one here, -4 to negative infinity. So it's going from -4 to negative infinity. As an inequality, we're saying x is less than or equal to -4. As an inequality, that's the statement we have. It's either going to be greater than or less than, greater than or equal to, less than or equal to. Because in an interval, if we have infinity or negative infinity, we'll only have the one number at the endpoint and then x in our symbol. The other one, 4 to infinity, means we have all the numbers greater than or equal to 4. And we know it's equal to because the 4 and -4 both have a bracket instead of a parenthesis.
I know we're doing this first, but on 21, so we just write it. We can figure it out by if it has a bracket or a parenthesis, right?
Yes.
So isn't the bracket greater than?
We can do that one here in a minute. What was it?
5 or bracket -5, comma 16.
So we'll do this one here next. So any questions on how we set up the inequalities or this statement here? Now the next thing we need to do is actually set it up in set builder notation, which always starts with a brace for these here x bar, and we close it off with a brace. That's it. Yes. Bracket.
Oh, so like that wrong?
We just need to put the line for equals.
Where?
Because it's here.
Oh.
Yes. So you don't need the bracket, you just need to show that they're equal. We use brackets in intervals.
Oh, so I probably messed up on these, I think.
Yep, that all looks right. That's all right. So we can look at 21. So the first thing we need to do is set this up because we're talking about the interval between -5 and 16. Our inequality would be -5 is less than or equal to x is less than 16. Because we have two numbers in the interval, we'll have two numbers in our inequality. And then we do this for set builder because this one's asking for set builder for this whole set. And the first thing I do with set builder, especially if we're talking about an interval or a set of numbers, is I write the inequality first, and then I put it into the set builder notation. Yes. Well, you're just missing the, because it's brace x bar. Yeah, once you got that, then you're good. And then 26. Because it says the set of all real numbers, what is it? Because it's all words, greater than 19 and less than 32. So I'm just writing the problem down at this point. So this is the main part we need to write in any interval notation. Or not interval notation, as an inequality like this here. So the smallest number we can have is what? The biggest we can have is? So we're saying that 19 is less than x is less than 32. If we wrote it as an interval, it would be 19 comma 32 with parentheses. But we can't put that in set builder. We need it as in inequality. Yeah, with our brace x bar, 19 is less than x is less than 32, then we have our answer. Does that kind of make sense? And 27, we're not going to specifically do it up here, but it's the exact same thing as, I think it's 20, and how you would write it. So 20 already has it written out for all real numbers x such that x is not 4, or I think it's -4, one of the two. You'll write it like that there, if that makes sense. But you won't use 4, you'll use the number they give you. Any questions on this here? So 27 is just like 20 in how it looks. Like, so the way 20 starts out looking, that's essentially what you'll have for 27. So give that a shot. If you're still stuck, let me know. Yes. Okay. We'll get back to it. Okay? Because what I want to look at today is this, parent functions. This is what we're looking at today. Now, parent functions, the reason they call them parent functions is because any other function of this type is going to look exactly like them. Just like how all of us have some resemblance to our parents, the same thing's true with these functions. They're going to have some resemblance to these here because these are the most basic of each type. The first one's constant. The main way we can identify a function as a constant function is because it's going to have f of x equals a number, or y equals a number. Yes. Linear is a line, straight line. You covered linear functions a lot in Algebra 1. And there's many different versions of it, but it's going to be a line, and the general function is just going to be x, or have just x to the first power. Absolute value. Absolute values kind of give themselves away because they have absolute value bars. If it's an absolute value function, it's going to have absolute value bars. If it has absolute value bars, it's going to be an absolute value function. And the graph, if we see it as a graph, it will be a V shape. All absolute value functions have this V shape to them. And the last type that we have is a quadratic. Quadratic is going to have this x squared term in it. It's going to have a square. Second power will make it be a quadratic. And all quadratics have this U-shaped graph to them. Questions on any of this so far? Now, what we're looking at today are transformations. A transformation is going to move the graph up, down, left, right. We can have reflections, so it can be reflected across a line. The main ones we'll look at is an axis, either the x-axis or y-axis, mainly the x-axis today. And vertical stretch and vertical shrink, which is going to make the graph either increase faster or increase slower. Now, the next part of our notes. All right, types of transformations. Now, we're going to write out the general forms of each one of these here. Linear. So I would write these down. Linear. Let's make sure to put these down real quick. Now with each part of these here, A, H, and K, there is another value B that will come into play later. But with these three here, the numbers that go in these places that are going to be in place of these values will tell us what kind of transformation we have. And we're going to describe it. And the first one we're going to talk about is what we call a translation. A translation moves the function up, down, left, or right. It's not going to change the shape, size, or orientation. It's just going to move it up, down, left, or right. Now, these two here are the first two types of transformations we're going to look at. Now, whenever we look at this, and especially compared to the general form, H is going to move it to the left or right. The H value moves it to the left or right. So the H value, this value that's added or subtracted inside the parentheses, moves it to the left or right. The K value is up or down. All right, guys, let's focus in. So if a number is added or subtracted outside parentheses or absolute values, it's going to move the function up or down. If it's added or subtracted inside parentheses, it's moving it to the left or right. So if we look at this here, the first one, g of x equals x minus 4. We're not going to graph it in its parent function, but we do want to describe or tell what is the parent function of x minus 4. What function would it be? Constant, linear, absolute value, or quadratic? So constant's key term is it's just a number. Do we have just a number? No, we have a variable. Absolute values, key features, it has absolute value bars, yes? Does this have absolute value bars?
Oh, no, I was
And quadratics have squares. The next one is, yes. This one here would be
that's the one I was yeah, I thought it was
absolute value. But this one up here, x minus 4, just has an x, yes? And the only linear. So this is a linear function. Now we need to describe the transformation that occurs, really from its parent function, f of x equals x. Well, the main thing it has is this, minus 4, yes? Is the minus 4 inside parentheses or outside? Outside, because there are no parentheses, so it's automatically outside. And if we have a number added or subtracted outside the parentheses, it's moving where? Up, down, or left and right? Up, down. So outside parentheses is up and down. Inside is left and right. So since we have minus 4, where do we think it's going? So negative 4. Where's normally a negative direction? Down. So this would be
that's all we see.
down 4. Now in the graphing calculator, we can actually graph the function. So we can say f of x equals x. So this is the parent function, the parent linear function, is this blue line here. Now, the function we were looking at is x minus 4, yes?
Yes.
So every point on this graph, this new one should be 4 points lower. If we graph it, this is indeed down 4. Every y value moved down 4 units. So that's it for that one there. Questions on this first one? Now the next one we did name its parent function. It is an absolute value function. Now is this one going to move up or down? Because we have it what? Inside the parentheses are absolute value, yes? Which is taking the place of h or k? H. H is left and right. So it's moving the function plus 1. So we say what? Right 1. And we can do this also in the graphing calculator, see what the graph looks like. Yes. So we can do absolute value. We'll clear this one out, say math. Absolute value of x plus 1. So this here is the absolute value function, the parent function. Since we have plus 1 inside here, it should move all the values 1 unit to the right. We tell it to graph, and it moved all of them 1 unit to the left. So it's not to the right, actually, is it? And there's a reason for that. So it's not actually to the right. It is to the left. Because our general function, I'm going to write it above it, is x minus h. And h is the amount that we move left or right. Now, if you look at the signs, because the sign of the general form is negative, the only way we can change from negative to positive is with another negative. So really what this is saying is that we have the absolute value of x minus negative 1. That negative and negative does give us our plus. But the biggest thing I will say with any of these here, when we're talking about transformations, if it's inside parentheses or absolute values, it's the opposite of what we think. If it's inside parentheses or absolute values, it is the opposite of what we think. So with this here, plus 1, it does give us the thought that we need to go to the right, but it's actually to the, and if it is negative, it's not to the left, it's to the right. Questions on these here? The next one we're looking at is a reflection. A reflection flips a graph over a line of reflection. A reflected point will be the same distance from that line on the opposite side. Now for this here, I'm going to put it down below. If A, the value in front of the parentheses, is negative, it reflects, it's a reflection, across the x-axis. If A is negative, it's a reflection across the x-axis. If A is negative, it's a reflection across the x-axis. We won't see one of these other ones today. If the value in front of x is negative, it's a reflection across the y. Inside the parentheses, if there's a negative sign in front of x inside the parentheses, it's a reflection across the y. Any questions on this so far? Okay. Let's look at this first one here. So p of x, so the one on top, negative x squared. So what would be its parent function, guys? What would be the parent function of negative x squared? Linear, quadratic, absolute value.
Quadratic.
Because it has an
Exponent.
exponent of 2. So this is a quadratic. So you got the next one for us?
I think keep switching from black to red.
It's switching between the touch. The next one is indeed linear. Now we need to describe the transformation for the negative x squared. Is the negative inside parentheses or outside?
Outside.
Outside. So it's a reflection across the x axis. If it's inside parentheses, if we have parentheses negative x squared, it's across the y-axis. Negative in front of x squared, negative in front of the x inside parentheses or absolute values is across the y. Outside, just having a negative out in front of it is across the x. Questions on this here? So if we looked at the next one, negative x would be what? A across the x-axis. Because it's in place of a, where a is at is negative, outside. Because this here, a is in front, would be in front of there. Since its value is negative, not so much the number itself, but it is negative, it's a reflection across the x. If we had it inside parentheses, then it's across the y. Questions so far?
Wait, what did you say?
Inside parentheses is across the y. Negative x inside parentheses would be across the y. When it's negative outside the parentheses, especially attached to the variable as a multiplier, then it's across the x. So let's look at these three here. Now this first one, okay. What kind of function is it? Linear, quadratic, absolute value, or constant? Linear. Okay, let's describe the transformation. So with our linear, we have x plus 3. Is the plus 3 inside or outside parentheses? So which direction is it going? So inside is up, down. So inside parentheses is left, right. Outside's up, down. So here we're going up or down, yes? Which direction? Up. How far? 3. Because if it's outside parentheses, it's going to go exactly like we see it. So up and down, if it's plus 3, it's going up 3. If it had been minus 3, we're going down 3. Up and down is just as it seems. The quadratic, we have parentheses, x minus 2, close parentheses, squared. Is this up, down, left, right, or a reflection?
Left to right.
It'd be left, right, because it's inside parentheses, yes? And which direction are we going, left or right? Right, because inside parentheses are absolute values is the opposite of what we think. Since it's minus 2, we think it should go to the left, but it's actually going to the And lastly, we don't have anything added inside or outside parentheses. We just have a negative in front, yes? So this is a yes. Questions on 2, 3, 4? Are you ready for the next part? Vertical stretch and shrink. A function is going to either increase or decrease faster along the y-axis. It'll increase faster if it's a vertical stretch. It'll decrease. It will not increase as fast when it's a vertical shrink. Now the way we determine this is by A. So guys, I would definitely make sure to get this down. Whenever a is greater than 1, it is a vertical stretch. When the value of a is between 0 and 1, it is a vertical shrink. Now the stretch and shrink, if it is negative, we're not looking at the negative, we're looking at the number itself. Because the negative, if the value of a is negative, it's talking about a reflection. The negative is the reflection, the value is the stretch or shrink. Questions on vertical shrinks or vertical stretch so far? Let's look at these here. So the first one we have g of x equals 2 times the absolute value of x. Well, this would be what? Absolute. Now the number in front is a 2, yes? The 2 is taking the place of a. Because that's where in the absolute value, the general form where a is, which means we have a vertical stretch or a vertical shrink. Now which one would it be? Stretch. Because it would be a vertical stretch because the value of a is greater than. Now we will say that it is a vertical stretch of, and we list the amount that it's stretching. Well, what is our value of a? So we say that this function has a transformation that is a vertical stretch of 2. We just list how much is being stretched by. Okay.
Oh, no.
Yeah, it's a quadratic. So it's in place of that a, yes. And it's a vertical shrink. Yes. Questions on A or B? Let's look at number 5. Yes.
So it's here.
Over here.
3 clicks of 1. It's called stretch of 3.
Yes. Let's look at number 6. This would be a quadratic because of our x squared. Is 3 over 2 between 0 and 1? What is 3 divided by 2?
Oh, divided by, yeah, -1.
So it's 1.5. Is 1.5 between 0 and 1? So is it a shrink? Yes. So if it's a fraction, really, we just need to see, is the denominator bigger or smaller than the numerator? Because if the numerator is bigger than the denominator, it's going to be greater than 1. If the numerator is smaller, it's less than 1. Absolute, because it has the absolute values. Is it 0.2 between 0 and 1 or greater than 1? It's between 0 and 1. 0.2 is less than 1. Questions on any of these here? We ready for the next part? can do more than one. We can have more than one transformation happening at the same time. So we have this function here. What kind of function is it?
That's an absolute.
Because it is a v, so it is absolute values, and we also have the function itself, which does give us the absolute value of r. So this is an absolute value. Absolute value function. Now, if we look at this here, there are two different things that we have. Because we have the 2 in front, and we also have the +1. What's the 2 in front of the absolute values telling us? It's bigger than 1, so it's a vertical stretch of and. So we have the +1. So its location is, so we're either going up or down or left or right. Absolute value. Because it's outside, yes? Outside parentheses are absolute values. When we add something to it, is up or subtract it is up, down. Inside, if it had been inside those absolute values had been x plus 1 inside there, then it would be left or right. Here it's up or down.
Wait, how do we know?
If it's outside, added or subtracted outside the parentheses or absolute values. So here it's moving up how far? And up 1. And that's it. We'll look at some more of these here doing more than one. Any other questions on this so far? Let's look at the next one. This one here is a quadratic, because we have the U shape and we also have the square. Now we have two of them, two operations. We have the 1/4 outside the parentheses and we have the 3 inside. So what does the 1/4 tell us? That it's a vertical shrink of,
It's left, right.
yes, it is left, right.
Left, right. We're going right.
Yes. How far?
2. No,
So what's our number?
it's 3.
Right, 3. So we subtracted 3, so we're moving to the right 3. And that's it. Questions on this here? Questions on any of this so far? I want to look at the second one here. So the second one on this page. So our function is this here. Now this is, again, a quadratic function. This time we have 3 transformations. We have 3 of them. The first one we're going to look at is the negative 0.25. Again, the negative in front of an x squared represents what? A reflection. The 0.25 does not connect to the reflection. The 0.25 connects to our stretch or shrink. So the negative tells us that it's a, yes, reflection across the x-axis. Now the 0.25 tells us it's a vertical what? Vertical shrink. Of 0.25.
And then it's right. Or it's left, right, but it's going right.
Almost.
Left,
Left, right's in parentheses.
so it's up.
It's up, down, because up, how far? That's it. So all of this here, I would refer back to these general forms and see where they match up. Because if the number's in place or where the h should be, inside parentheses are absolute values, it's left, right. If it's outside where k is, it's up, down. A tells us either reflection across the X or vertical stretch or shrink. Questions on any of this here? If you finish the homework assignment from 1.1, yes. So it's almost time to go. You will have the entire class period tomorrow to work on this because I will not be here. It will be a makeup day. If you do have questions on any of it, we will go over them at the start of class Monday.